Only this direction we are taken, not the other way around. Now, once you have taken the direction, right? So, what did I tell you? This resistor is there, na? Its polarity will get established by the current direction. So, current direction is like this. So, that means it is going like this, and like this, and like this. Correct?
Mm.
So, that means here it is plus, here it is minus. Now, what did I tell you? If I want to write KVL for this loop, right? Now,
Mm.
I have an individual loop here, right?
Yeah.
This is my individual. Just a second. This is my individual loop over there. So
Mm.
KVL for loop 1. Loop 1. What is my loop 1? This is my loop 1. Plus minus V1, correct? Then
Mm.
R1 and R2. But if you notice here, okay, this is a branch resistor, okay, R2. Here,
Mm.
here at this node, if you notice here, this is a node, na, more than 3 currents are meeting here, right? So if I1 is entering like this, right? And I2 is going like this, right? I2, because the direction is like this. Can you notice over there, right? I2 is moving like this, like this, like this, and like this, correct? I2 is going like this. So I1 is entering this node, correct? But I1 will get divided into two paths, na? One is this also, right? So
Mm.
current through this will not be I1, it would be X, right? It would be X, it's a different current. So R2 here is a branch resistor, okay? So current across the branch resistor, a resistor that comes in between two loops, right? This is loop 1, okay, and this is loop 2. So a resistor that comes in between two loops is called a branch resistor, right? A
Yeah.
resistor, okay, a resistor, okay, that is between two loops, that is between two loops is called as a branch resistor. Branch resistor. Okay, so it will have a branch current. So what would be the current? I1 is equal to, now you see here. If you apply KCL, I1 is entering, right? What is leaving? X plus I2. So X plus I2 is leaving. So what is the value of X? X value would be I1 minus I2. Okay. So here the value of X will not be I1. It would be I1 minus I2. Okay. But this current direction of X is like this, right? Again like
Yeah.
this. So here also this is plus minus. Now you have to write the KVL as I told you, right? So current is going like this, correct? So here it would be minus V1, correct? Here, because of the current direction, this is plus minus established. Plus minus established. And the tail is again in the direction, it's entering through the plus. So it would be plus I1 R1, correct? And here again it is entering via the positive terminal. Plus x into R2, right, is equal to 0. But the value of x is I1 minus I2. So it would be minus V1 plus I1 R1 plus I1 minus I2 into R2 is equal to 0. Correct? Understood?
Mm.
This is how you write KVL. Now, can you write the KVL for the second loop? Now,
Okay.
I wrote it like this. Now you help me with the second loop. Okay, if you are able to do yourself, okay, then it is very simple. Uh, I wrote this as R1. Okay, now you see here, this is your R2, correct? Now, for the second loop, can you write R2, and this is your plus minus V2, right? This is
V1.
just a second, R2, and this was your R3, right? Just a second, just wait a minute. R1, R2, and uh, and this was your R3, and this is your V2, right? So for the second loop, for the first loop, you took this as I1, right? This was your X, correct? And for the second loop, now this is your I2, right? Now you see here, this will not change, correct? So that means here and here also, see, here also I2 is getting added, right? What is happening to the X there? The direction of X is reversing. It is
Mm.
going like this for this loop, right?
Yeah.
Because see, that direction of X was governed by I1, right? This X
Mm.
was governed by I1. Now this X will be governed by I2, like this, correct?
Yeah.
So x direction is now reverse in this scenario. X is going like this. So I1 will not change. I1 is incoming. X is also incoming, right? And this is outgoing. So if you apply again KCL there, so you see that I1 plus X is equal to I2. So X value changes. I2 minus I1, correct?
Mm.
Yeah.
Yeah.
Now there is a simple trick. Simple trick. Now when you are taking for the loop 1 X value, for the whichever loop you are taking, that loop minus the another loop value would be X. I1 minus I2. See here. I1 minus I2. When you are taking for the loop 2, it would be that loop current, that is I2 minus the other loop, I2 minus I1. Okay. See here the X value became I2 minus I1. So in the next loop, this X value will become whichever loop you are taking. So here you start. So here you came to know this X is okay. And the direction is, it is like plus. See, this is your plus and this is your minus. So always remember the resistance is there, na? Always in
Mm.
90% of the cases, see, it will always enter through the positive terminal, right? Positive and minus, because this will be entering to the positive. So it would be x into R2, okay, plus I2 into R3, right? Plus V2 equals to 0. Did you understand? Why
Yeah.
plus? Because this current is entering via the positive terminal, right? Plus V2.
Mm.
Here it was entering via the negative terminal.
Negative
This
terminal.
this this is for KVL of for loop 2, right? For loop 1, you tell me. For loop 1, it would be minus V1, right? Plus
Mm.
I1
R1.
R1 plus
I1
plus
plus uh
yeah
X. What's that?
x, yeah, plus x. But
R2.
what would be the value of x there? X value
Uh,
would be that loop minus the other loop current, right?
yeah.
X value would be I1 minus I2 into
Uh,
R2 is equal to 0, right?
yeah.
Understood?
Mm.
Okay. Now, if you have understood this, okay, can you solve this problem? Just a second. Let's say this is a problem. This is your plus minus 15 volts. Okay. This is
Mm.
your 5. Let this be your 10. Now let here be plus minus. I'm just putting a voltage source here. 10 volts. Just apply the concept. Don't get irritated by a nature of the circuit. You may get frightened. Na, that you just apply the concept. 5 ohms, 10 ohms, 6 ohms. Correct. So how do you start? Tell me. Here you start with this. Yeah. First you have to name the
Direction.
I1 and I2, right?
Yeah.
Like this. Again, so this current, if you are looking for the loop 1, this current for the loop, this is your loop 1, right? This
Mm.
is your loop 2. For loop 1, this x value would be equal to that loop current, that is I1 minus I2, right? And if
Mm.
you are writing for loop 2, then loop 2 current minus the loop 1 current, okay? Loop I2 minus I1. So in short, x is branch current, okay? Branch current. And basically, branch current appears where? When there is a branch which is common between the two loops. X is a branch current which is, okay, which
In two,
separates the
two.
two loops, right? Two loops. Okay, okay. When we are writing KVL, when we are writing KVL equation, KVL equation, KVL equation, its value would be equal to whichever loop you are writing, okay, its value would be equal to, its value is equal to whichever loop you are writing the equation, whichever loop, okay, equation is written minus the other loop, okay, minus the
Other.
other loop current. So that means if you are writing for loop 1, the value of x would be equal to the value of
I1
x, I1
minus
minus
I2.
I2. This would be for loop 1, correct?
One.
And for loop 2, what would be this value of x?
I2 minus I1.
Very good. You understood now? Now you understood 100%, right?
Yeah.
Correct.
Yeah.
Now you write the KVL. Start writing the KVL equation. See,
Minus 15 volts.
minus 15, correct. Here, see,
Uh,
here the polarity will get established by plus minus. In short, you
yeah.
remember resistor and across the resistor, it's always positive.
Mm.
Across RLC, okay, it is positive, right? Why it is positive? Can you tell me? Because see, polarity is also, see, current direction is this, and polarity is also getting established by this only, plus minus. So it is always entering via the positive only here. Here also you see the polarity is like this, plus minus, and entering also like this. So it would be minus 15. Only you have to take care when you are checking for the voltage source, right? Here it became minus 15. Come on, tell me then.
Then I1
I1?
minus I1.
No, no, no. Here 5 into I1, na. This was voltage. This is resistor into. See, this is KVL you are writing. KVL means V you are writing. V by I is equal to R, right? So V would be I into R, na. So there
Yeah.
R value is 5. So it would be 5 into I, na. 5 into
Mm.
I1, right? This value is 5 into I1, correct?
Yeah.
Then here plus 10 into X, but X value is I1 minus I2, right? Then here it
Mm.
is entering via the positive, like here it was entering via the negative. So you'll write plus 10 volts is equal to 0. Understood this?
Yeah.
If you have understood this, can you tell me for the loop 2? Equation for the loop 2. Come on, tell me. Loop 2 is this one, right? Loop 2 is this 10 ohm, this plus minus 10 volts, right? This 10 ohm, this 6 ohm, and this is your, how much is that? 4 ohms. I did not write that. 4 ohms, correct? Now for this is your I2, right? So this is the direction, and this is your 6 ohms. So this is your I2. Here also I2 is going. Here you know X is going, right? Here the value of X would be equal to, for loop 2, it would be I2 minus I1. So start from here. Tell me, what would be the value? First value?
Minus 10 volts.
Okay, very good. You are starting from here, no issue. Minus 10 volts, very good. Then
Then plus 10
10
I2
I2, very good.
plus.
No, not I2. See here, this is a branch, na beta. This is a branch, right? This is
Yeah.
separating the two loops. Here the current is
Okay.
X.
I2 minus I1
Yes, I2 minus I1. Very good. Then here,
plus
uh,
6
uh,
I2
let's say, very good. Uh,
plus
uh,
4
very good. Very good. 4.
I2.
Very good. Very good. Very good. Shabash. This is the equation you got. These are the two equations, right?
Yeah.
Now you are understanding, right? You have to
Mm.
be careful when you are taking the branch. See, what is the mistake that can happen while you are solving this mesh analysis? The only mistake will happen in the branch register, which is in between, right? So you will write like here you made this mistake 10 I2. It won't be 10 I2, it would be 10 I2 minus I1. Here it would be,
Mm.
when you are taking for this, here it would be ulta 10 I1 minus I2. That is the only mistake, right? Rest all things you know. Whether this is voltage is like this voltage source, then overall polarity is negative. If the voltage goes like this, if it enters via the positive terminal, then the overall polarity is positive, right? And as far as resistor is concerned, it is always positive only because of the current direction. That, but you see, okay. Now you got this equation, you can solve this equation. Minus 15, okay, plus 5 I1 plus 10 I1 minus 10 I2 plus 10 equal to 0, right? This was my first equation that I got here. KVL equation minus 15, 5 I1 plus 10 I1 minus I2 plus 10 volt is equal to 0, right? Same equation. So this is 15I1, right? So this is 15I1 minus and 10 minus 10I2
Mm.
minus 5 is equal to 0. So if I take this 15I1 minus 10I2 is equal to 5, right? I can
Yeah.
also take 5 common. 5 is equal to 3I1 minus 2I2. And if I take 5 here, 5 ones are right. So it would become 1. So the equation becomes 3I1 minus 2I2 is equal to 1. Correct?
Mm.
Hmm? Okay. What else is there? The second equation I have 6I2 plus 4I2 that becomes 10I2, right? Plus 10I2 minus 10I1 minus 10 equals to 0. This is the second equation. You already told me this equation, right?
Mm.
See here, you told me na 6I2 plus 4I2, 10I2 minus I1 minus 10 volts. Same thing I wrote, right? Minus 10 volts, this thing, right? So this becomes 10I2. Uh, then that was 10I2 again, 10I2 minus I1 na. So this becomes 20I2, 10I1 minus 10 is equal to 0. So this becomes your 20I2 minus 10I1 is equal to 10. Correct. If you take
Mm.
this common 10 here, 10 if you take common, it will become 2I2 minus I1 is equal to 10. Correct. So
Yeah.
10 cancels becomes 1. So I2 if you take that side and I1 if you take this side, 2. So this is your I2 is a 10, sorry, I1 if you take this side, I1 will go this side, so it will remain 2I2 and this one value will come here, so it will become minus I1. So I1 is equal to 2. So these two equations you got, equation 1 and equation 2. Now you can solve these two equations, right? So if you solve these two equations, what is the value that you are going to get? Okay, so you got the above value as 3I1 minus 2I2 is equal to 1, correct? And this was I1 is equal to 2I2 minus 1. So just put here. So this becomes 3, 2I2 minus 1 minus 2I2 is equal to 1. So this becomes 6I2 minus 3 minus 2I2 is equal to 1. So this becomes 4I2 is equal to 4. So therefore I2 is equal to 1 and I1 is equal to 2 minus 1. Correct? I2 is equal to 1 and I1 is also equal to 1. Correct? I1 is also equal to 1. Right? So X is equal to that value is equal to I2 minus I1 or I1 minus I2. In both the cases that is 0. Correct? Understood? Can you solve one more question? See, for
Yeah.
me, now suppose if I take a dependent source wala question, okay? Let's say I'll ask you three equations. Okay. Mm, You try yourself, huh? Will you try? First, you try a two voltage source, then I'll show you for the 12 volts, right? Plus
Mm.
minus. This is your resistor 2 ohms, right? This is your 12, and this is your 4 ohms. Okay, this is your 4 ohms, this is your 12 ohms. Okay, so this is your 9 ohms, and this is your plus minus 8 volts. This is your 3 ohms. Okay, so this is 9 ohms, this is 3 ohms. Okay, get the value of I1 and I2. Okay, get the loop currents. Get I1 and I2. So, how do you go about this? First step is to assign the current direction, right? This is your I1, correct? This is your I2, right? And
Mm.
this is X for the loop. Now, apply KVL for loop 1, right? Tell me. See here. This is like this, like this, like this, and like this. Tell me.
Um.
What would, tell me.
m- Minus
Ah,
12.
very good. Then,
Mm.
then move like this, na? Ah,
Plus 2.
plus 2,
I1.
shabash. Then here,
Mm. Plus
Huh?
12
Huh?
I1 minus I2.
Very good. I1 minus I2. This is the catch here. Okay, then here.
Then plus 4
Uh,
I2.
Not I2. How I2 will come? I2 is there, na? I2 is this side, correct?
Oh, I1,
I2 is
I1.
this side. So here I1 only, na? In this loop, I1 only. Only this is the branch register. Rest all the things will have I1, right?
In the, like, we wrote I2 in the 2 I2, we wrote, like, after 12 plus.
Minus 12 plus 2. Sorry, here, sorry. 2 I1 only.
Yeah, yeah.
Yeah, good. Okay, 2 I1 plus 12 I1 minus I2 plus 4 I1 is equal to 0, correct? Open this up. So minus 12 goes this side. So it becomes 12. So this is 2 I1 plus 12 I1 minus 12 I2 plus 4 I1. So it becomes 16 I1. Okay, minus 10 I2 is equal to 12. If we take 4 common there, right? 4. So it will become 4 I1. No, 4 we can't take common. 2 we can take common, right? 2. So it will become 8 I1 minus 5 I2 is equal to 12. So 2 ones are 6. So 8 I1 minus 5 I2 is equal to 6. Okay, this is the loop 1 equation. This way we can do via using the calculator. Now can you write for the second loop? You try. Ah, just a second.
Mm.
Try for the second loop, maybe. What would
12,
be the equation?
you know.
Minuta.
Yeah,
Ah,
yeah.
tell me what will be the
Minus.
equation for the second loop.
So your voice is a bit low.
Yeah. Sorry. Tell me now. You tell me. Now voice is
Mm.
okay.
Yeah.
Tell me.
Minus, what's
Yeah.
that number?
From
8.
where you are starting?
Minus 8 plus 3
Why minus 8 plus 3? Why minus 8? For
from
loop 2,
voltage.
loop 2 will start na. Loop 2 is
Yeah,
this I2 na. I2 is this. Correct?
yeah. From 12 we'll start.
Okay. Start from 12.
12
Ah, okay.
uh, plus, no,
12 what?
12
12 is
I2
into
minus
some current. Huh?
I2 minus I1.
12 into
I2 minus I1.
very good because it's a branch resistor. Whichever loop. Okay.
Yeah.
Okay. Shabash. Then
Plus 4 I2
plus 4 I2 shabash. Then
plus, no,
uh, why
minus 8.
minus? Why minus? It is
No,
entering
it's
the positive,
plus.
right?
Yeah,
Here minus because it was entering the negative.
negative. It's
So what
plus
it
for
here it will come?
plus.
Plus it will come, right?
Yeah.
Okay. Then
Let's see. Uh, then plus
hmm,
uh, 3
uh,
I2.
shabash is equal to 0. Correct.
Hmm.
Only two things you have to keep in mind. In the
Yeah.
voltage source, if it is entering the negative current, then overall polarity is negative, right? If
Hmm.
it is entering via the positive current direction, then overall polarity is positive, right? It can be, see here, you see it is entering via the positive, right? And in the branch resistor, you have to keep in mind the current would be that low. In all the other, it would be the same current. See, suppose here it is I1, here it is I2, right? Are you understanding?
Yeah.
12 I2 minus 12 I1 plus 4 I2 plus 8 plus 3 I2, correct? Is equal to 0, correct? So this is 12 I2 plus 3 I2, that is 15 I2, right? Any more I2 is there? 7, or this 4 I2 is also there. So 19 I2. 12 plus 4, 16, 19 I2 minus 12 I1 is equal to minus 8, right? If I write this as 12 I1 minus 19 I2 is equal to minus 8. Just use my calculator. Okay, because I can use the calculator you brought today.
No, sir.
See, where is your calci?
I
Please
went,
get
uh, I went out. I need to buy again.
please
It's in
get one
hostel.
991 MS. You check with your this thing, na, because
Yeah.
calculator is very important.
Oh,
Hmm.
yeah.
I will teach you how to use the calculator also. That will save you time. Okay.
Mm.
In the examination, na, you will feel confident when you have the calculator in hand. Right. So I'm getting a value of I1 as 1.67 or 2 by 1.67 and the value of I2 as 1.478. This is the answer. Okay.
Mm.
This is how I will be. Okay. Uh, just a second. Okay. Understood how to use this and huh?
Mm.
Okay. Now, can you do me one question like this with a dependent source if I show you? See, I'll show you that Thevenin I was telling you, before this class enters, I'll show you that Thevenin theorem. See, this resistor I showed you that day, this was 10 ohms and this was 5 ohms. Na? This was 10 and this was 5 ohms. And let's see, this was 150, right? Now, Thevenin theorem says this is the open circuit voltage. So, whatever this resistance is there, Thevenin procedure is that, see, the overall current here would be equal to IL would be equal to 150 divided by 15. So, that is 10 amps. Correct? Hmm? Right? Huh?
Yeah.
Actually, it is not the IL value here is basically 150 divided. See, this is the load resistor RL. Actually, it is 150 divided by 10 plus RL, right? Then it came 10 amps. Now, when I apply the Thevenin theorem, what I do is that I remove this, right? And get the open circuit voltage. So, when I'm removing this, what is happening? This is becoming, current here is becoming zero. When current here is becoming zero, the voltage here is 10 into this current zero. So, this is also becoming zero. So, the open circuit voltage V Thevenin is equal to 150. And the
Mm.
Thevenin resistance that I have to see is that is this side. Okay, when I remove this, okay, so only this 10 ohm is left. So this is my Thevenin resistance. Now I Thevenin, okay, should be equal to 1.